If you're into CNC routers or any kind of machining, then one of the tools that needs to be in your toolbox is a set of calipers. In this video, we're going to dive into digital calipers, all the different ways you can measure with them, what they're capable of, the names of every element on here, and how to make adjustments to them, and a couple other things that you need to know about. By the time you're done with this video, you're going to know everything digital caliper. idcwoodcraft.com. I'm Garrett Fromme, CEO and owner of IDC Woodcraft. IDC Woodcraft is the company that you and other CNC creators get their router bits from. In this video, we're going to dive deep into digital calipers, and I'm going to teach you all the ways that you can measure with digital calipers and the names of all the elements on here and a lot of other information. Now, what we're going to do is we're going to go through the IDC Woodcraft brand digital calipers. These are industrial grade digital calipers. There's industrial grade and there's non-industrial grade. You want to know what the difference is. So we're going to cover that. But we're going to go through this as if you ordered a set from IDC Woodcraft. We're going to open a box and we're going to go through the whole thing. If you don't have digital calipers, down in the description of this video, there will be a link to get yours at IDC Woodcraft, or you can just go to idcwoodcraft.com. When you get your digital calipers, they're going to come in a plastic case just like this. When you open it up, you're going to get several things. You'll have the instructions of the calipers. You'll get the silica gel, a battery or two. In the case of IDC Woodcraft, you'll always get 2 batteries, and then we also give you both a Phillips head and a bladed screwdriver to make some adjustments. And of course, you will get your digital calipers, and they will come in a bag. Before we dive into how to use calipers and tell you about the different components, I want to talk to you about the 2 grades of digital calipers. There is industrial grade and non-industrial grade. And the differences are the electronics inside the calipers here, the accuracy with which it can operate, the construction of it. There are some plastic ones. When it comes to calipers, those plastic ones, like that cost $9, $10, they're a waste of money. Look at it this way. You spent plenty of money on your CNC router. Why are you going to go cheap on a set of calipers, a measuring tool that you need to get some precision out of? Plastic calipers are a waste of money. When I say accuracy, how many decimal places can it go to, and its repeatability. One other aspect about accuracy is how close do digital calipers read. You should expect for calipers, no matter what you get, an accuracy of plus or minus 0.01 inches or plus or minus 0.02 millimeters. And what that means is, let's say we have something that's exactly half of an inch, 0.500. This should read to an accuracy of plus or minus 0.1. In other words, you would get a reading on the calipers of 0.499 to 0.501. And that's what we mean by the accuracy and tolerance. So the IDC Woodcraft brand digital caliper, these are industrial grade calipers. They are moisture resistant, meaning you can't immerse them in water or oil and let them operate for a long period of time, but they can get dirty, moist, get oil on them, and they'll still work. So this is how digital calipers work. Inside this part of the main shaft here is a magnetic scale. And it's like magnetic tape, like a tape player would be. And then here is the reader head behind the display, the electronics that are inside the calipers themselves. And as the calipers move back and forth, they're moving, the reader head is moving across the tape, and you are getting your measurement that way. So let's talk about the names of the different components and what they do. So you have the main scale here, or also known as the blade, which will have the brand on it, which in this case, IDC Woodcraft. It'll have a scale on it. Here on the bottom, you have a metric scale. On the top, you have an inch scale. For digital calipers, these are just reference numbers. Nobody ever uses them. We just count on the display. And then we have the main display housing, which holds all the electronics, and it's got several switches on it, which we'll get to. And then we have the macro movement, thumb bump, whatever you want to call it, where I can just grab it and move it back and forth. And then we have the thumb wheel for micro adjustment. Now you can see generally when we're working with calipers, we're holding it by the blade, and then we can move it around with our thumb, and it's generally a right-handed tool. On top we have a locking screw. So when you're making a measurement, close down on something, and you want to hold that measurement, you just lock down that screw. You don't have to lock it tight. And then you can take it off whatever device, and now you've got that number locked in. These jaws, the lower jaws, as they are called, are for measuring outside measurements. So in this case, we're going to look at the outside measurement of this shoulder bolt, which, well, let's zero out first. Let's make sure we're zeroed. Okay, so we're zeroed. And we can come up and just lightly roll it onto the shoulder bolt. Now you see I am spinning that thumb wheel, which means I'm just putting on a very light pressure to make it touch down, and that's it. We don't want to push on this. When I say you don't want to push on this, I'm meaning the pressure on the thumb wheel. When you're measuring something, you want to bring the jaws in until they just touch down and stop at that. If you overpressure on any set of calipers, you're going to get a misread. So you can see I'm pushing on them now, and what I'm doing, I'm stressing the entire body. It doesn't matter whether you're using ultra high-end calipers like Brown & Sharp or Mitutoyo, or you're getting the ultra cheap, you're going to get that. So you just want to use a nice, gentle, constant pressure, and when it touches down, then you're going to get your read, and you'll be okay. These jaws are for measuring outside dimensions. We got this block of wood here. It's for measuring something like that as well. The upper jaws are for measuring an ID, or internal diameter. So we have a collet here, which is a 1/2-inch collet, and we can put that in. We have to be careful of little grooves because the jaw will drop into those grooves. So I'm just going to lightly push on that and just push it out just a little bit. I'm lightly putting pressure and I'm rolling it, and it's dropping into the little cuts. So let's get something else. We're going to get this nut here, and I'm going to just measure the nut. Now, when you measure an inside diameter, you want to be careful not to cockeye the tool relative to the diameter. So that's why we gently rock it back and forth, or rock the item we're measuring back and forth until it falls in. It'll be parallel or perpendicular. It'll be parallel to the device. It'll be perpendicular to the jaws, and then we can get a measure on it. So this is 1.128 ID. This is for measuring anything internal, and this is for measuring anything external. Now, there's another aspect to this, which is the depth gauge. This is for measuring the depth of holes and such, where you need to get a step. You can't get anything else in there. So, for example, on this cam clamp, we've got a little step diameter, and then it steps down to a smaller diameter. So what I'm going to do is I'm going to put this stick the depth gauge out quite a bit, and then I'm going to put it against that step there, and then we're simply going to push the main body or the blade down until it bottoms out. And I want to make sure that I'm not holding it like that, because I'll get a mismeasurement. The step gauge will actually be sticking out a little bit further than what it needs to be. So you just want to get a feel for it so that the digital calipers are sitting flat. And now we can take a look at our measurement, and that hole is 0.208 inches thick. Now, we have two diameters here. So how do we get the depth of this inner step? We've got the top of the material, then we have the distance down to the first step, which is 0.208, and then we have the rest of the distance. Of course, we can measure that, this depth here with the step, and then we can measure the difference here and then subtract it. But we can let the calipers, or the digital calipers, do the math for us. And here's how we do that. This comes in with the 0 button. So when you get your calipers, first of all, it's a good idea to clean the jaws. And the way I clean the jaws is by putting a piece of paper in between them, lightly closing the paper, and slide the paper out. And then make sure we're getting a 0 measurement. When we push the calipers to their 0 point, we're just pushing it until there's just minor resistance, and then we can spin the thumb wheel while we're giving it minor resistance. So I know that I'm zeroed out. So what I'm going to do is I'm going to use the depth gauge, and I'm going to get the depth of that first hole. And that first hole is 0.2075 in this case. And then we're going to zero it out by hitting the 0 button, which is right here. And now I can put the depth gauge all the way down through the other hole and bottom out at the bottom of the cam clamp, and then I'll just run it down until this part touches the top here. And now I know that the depth of that second hole is 0.5205. So now we have one more element to learn on the digital calipers, and that's the step gauge. So there's lots of different uses for that. I don't have a great example here, but we'll just go with this clamp right here. And what I'm going to do is put the part of the clamp on this, against this bottom step gauge, or the movable step gauge, and I'm going to slide it all the way down until it stops. And now the step depth is 4.296 inches, roughly from here to here. Given that it's wood, that's not very accurate, but that you get the idea. Now again, we can take advantage of this zeroing factor. Let's say we want to know the difference in diameter between the shoulder and the head diameter. So I can come over and measure the diameter of the head, get a 0 on it, and then close down on the shoulder bolt. Now I'm going to get a negative number because the shoulder is smaller, but I know that it's 0.118 inches less in diameter than the head of the bolt. So let's go with something else here. I'm going to just close these down, just lightly push. I'm going to zero it out, and we can check repeatability by constantly hitting the jaws with the same feel. We got excellent repeatability on this. I expect this out of digital calipers. Let's say we want to get the length of the shoulder. Well, that's kind of hard to measure. You can take this jaw and get an eyeball on it. So I'm holding the jaw against the top of the shoulder of the head, and then going to come down and eyeball that, and that's a general length. So I can assume that this is a 1-inch shoulder just by the number, but that's not very accurate. So here's how we can do this even better. We can take the step gauge, and I'm going to zoom the camera in just a little bit. And I can take the bolt and push it against the step gauge and let it slide down until it hits the shoulder. And I want to make sure that it's sitting flush to this part of the body. Now we've got that. We're going to zero it out, and now I can push that all the way down until the head of the bolt touches, and then make sure that the step gauge is touching the end of the bolt, and now I know that the shoulder is 1.003 in length, so it's just over 1 inch long from this point to this point. I've got a bit more to show you about digital calipers. We have to talk about the adjustment and such, but if you're doing CNC routing, then you definitely need to get a set of calipers. We use it all the time. I'll show you exactly what I mean here in just a moment. So that's how you work with digital calipers. You can get these industrial calipers at idcwoodcraft.com. You can see it's branded right there. One other thing is these are auto off. Now it's got a power button on it, which is right here, where you can turn it off. But the minute you move it, it turns back on, and in about 2 minutes, it'll turn itself back off. It will not lose its position. If it turned off right here, when it turns back on, it's going to read 0.7860. The uses for calipers in your CNC woodworking would be to make sure your CNC router bits are the diameters that they're supposed to be. For example, this has a 1/4 inch shank dead nuts on it, and this is a 1/4 inch diameter router bit. So when it comes to measuring oddball shapes like this, we generally want to get as much of that screw as we can, and it's measuring about 2, and we have to roll it just a little. And you'll have to roll it until you know that you've hit a high spot, which is about right there. So 0.248, 0.249, this is a 1/4 inch diameter router bit. It's a hair under because of the grind for the blades on the router bit. The next thing is when it comes to replacing the battery. Now here's the battery compartment right here, and you can just use a fingernail or the the bladed screwdriver. Now its battery compartment is a little bit tight, and you just pull that piece out. Be careful, don't go too fast. You don't want it to fly across the room. And just hold on to it. And now here is the battery compartment. And the power has gone off because we've taken the battery out. This is the battery here. This is the plus side of the battery, the wide side. And when you put it back in, if you put it in the wrong way, the battery assembly will not seat. Now, we push it all the way down and you see the calipers turn back on, and they turned on in millimeters. So you simply press the middle button, which is metric to inches, and then we can zero it after we clean the blades. Don't need to, it's already re-zeroed. One of the common ways you will use your digital calipers is to measure your material thickness for your CNC project, because not all CNC projects are the thickness that they're listed as. So this is 0.7515, and there's some masking on here, so that's accounting for it, but you'll often find that material is thinner than what they are selling it to you as. For example, this piece of pine right back here is definitely going to be thinner than 0.75 or 3/4 of an inch like they advertise. It's actually 0.689 inches. So here's how I use digital calipers a lot in my CNC router work. After I have my material secured down, I want to make sure I know the depth of it, and I'll take the depth gauge and I'll just drop it down on the spoil board along the edge of the material, and then I'll slide the depth gauge down and get a read on it. And so right now this is 0.77 in thickness. So if I set my material to 0.75, the router bit is actually not going to cut all the way through the material. So you always want to do that, and it's good to measure across several points. This is 0.771. Over here is 0.764. In this part of the video, I want to show you why you have a bladed screwdriver in your kit with your calipers. And that's to get your calipers back into adjustment if they go out of adjustment. Something that's probably not going to happen to you because you don't use them as much as someone like a machinist would use them, someone who's using them all day long. Over time, there's a little device inside of the calipers that can loosen up and make the main body start to get loose on the blade, and that has to be brought back in. Now, like I said, that happens with a lot of use over a long period of time, but you need to know how to adjust your calipers if they start to go out, what to look for. Now, I took these out of adjustment intentionally so that I could show you how to do this. But first, I need you to understand how the inside of the calipers work so I can tell you how to adjust them. And I'll explain this to you by drawing a picture, and then I'll show you how to make the adjustments. So we have the two components of the caliper, the two main components, the blade, or the fixed part of it, which is attached to the top of the lower jaw, and then the sliding assembly, which moves back and forth along the blade. And what we have is the blade itself, right here. And then we have the housing that contains all the electronics. And so we will draw that box right like that. And of course it's attached to the depth gauge, which runs off just like that. This part of the calipers needs to be perpendicular or parallel with this, and it can't have any play. If you look at this one right here, and I'll hold it still, and I want you to watch right in this area, I'm going to wobble it back and forth. So when I wobble it, there is play in the calipers. Let's see if I can give you a better view of that. So you can see that the calipers have some play in them. It's kind of hard to get that play in there, but it's there. There we go. Now you can see it. Well, right here, there are two screws. This one and that one. And those two screws are down inside the housing. So we get focused, just like that. And they are pressing against something called a gib. A gib is a little bar that is inside of this housing. And that bar, if you get this play, in your calipers, just like that, then what has happened is this bar has loosened up its pressure against the blade of the calipers right here. And so we need to bring that adjustment back in, where we need to just bring that, drive these screws down until that bar is against the blade and it's not actually pushing. We don't want to screw it down so hard that we can't move the calipers, which you can easily do. So I know that the back side is still fixed because I intentionally loosened this up. And what you need to do is take the bladed screwdriver that you get with your calipers and bring it in here and turn it just like a screw, lefty-loosey, righty-tighty, and we're going to start to tighten that screw up. And I'm just going to bring it to a point where I can just feel the screw touch the gib, and the gib is now touching the blade. And then I'm going to move it back and forth. Now I should be feeling just a minor little bit of resistance. We can tell if we are not tight enough by a repeatability check. You simply just keep doing this, and if you're not getting good repeatability, then you know that's out. And I can tell when I'm giving a little extra pressure, it's really going out. So we're going to put a little more pressure on this screw. There we go. And now I've got a little bit of resistance, and I can push it against or close the jaws. We should clean the jaws first, just to make sure, because I've been handling it with my hands. This is a good practice to get into every time you pick up your calipers, especially if you want to get the most accurate measurement you can get. And we are going to close the jaws. I'm zeroed out. Now I'm going to put the same pressure on them. There we go. I'm going to put the same pressure on them each time. And it's a little bit snug, but I'm getting a pretty consistent read on that at 0.05 to 0.0005 to 0. So that means I've got this adjusted in properly now. And if I try to wobble this, I can't. It is now adjusted properly. These calipers are back in service. Now the Phillips head screwdriver would be if you want to open up the housing, you would peel away this table here, and underneath it are some Phillips head screws, and you can take it apart that way. I've never ever taken apart calipers. As far as this adjustment goes, it may be a very long time before you actually make that adjustment. I've used them for years before I had to make the adjustment. Now, one of the precautions when it comes to digital calipers is dropping them. If they land on the prongs for the inside measurement, or the jaws for the outside measurement, or any other part that does measuring, you're going to damage it. And if you do that, then what you need to do is take a stone, a sharpening stone, and come across and just gently grind it until it's flat again. Always handle these with care. Wipe them down when you're done, put them back in the case, close the case, make sure it's locked. If you need to get a set of calipers, then you can get these at IDC Woodcraft. If you're doing CNC router work, you have to have a set of calipers. It's just one of the necessary tools that we have to have in our toolbox. So I'll put a link down below in the description for these calipers here. If this video is helpful, please give me a thumbs up and a comment down below. Have a great day, better tomorrow, and happy measuring. idcwoodcraft.com